Hello guys, welcome to another video in the series of coding. Today we are going to do a problem that is called trapping rainwater. So we are given an array of n non-negative integers which represent the height of blocks. If width of each block is 1, compute how much water can be trapped between the blocks during the rainy season. It's one of the very important problems of the array topic, and let's get started to it. Okay, let's try to see how much water can this entire structure store, right? Suppose let's say it is raining and water is going to fall from the top. So what will happen? Each block will be able to fill water, right? Let's say this block will try to fill water. Okay, if it tries to fill more water than this, what will happen? It water will spill from this side, right? So how much water can it store? It can store only up to here. If it tries to store more level than this, water is going to spill from this side. Okay, what about this block? Can it store any water? No. The moment it stores one drop of water also, it is going to spill because there is nothing on the left side to hold it, right? Okay, from the right side it can store water, right? Because this guy will be able to hold it, but from the left side of this block there is nothing to hold the water, right? There is nothing to hold the water. If it stores water, it will just spill. So this block will not be able to store any water. Okay, let's go to the next block. This block, what about this block? Now here it can store water, right? Here we can store water up to this or even more. Okay, let's store even more. Can we store it? Yes, we can. Okay, what will happen if you store even more? Then it will spill. So this is the maximum it can store. What about from the right side? From the right side it will not spill because you can store up to here, right? Because this block is holding it, right? This block will hold it, so you can store water. It would have it cannot spill like this. It cannot go slanting, right? It would have spilled if you try to store more height than this, right? If you try to store more than this, then it will spill. But in this case, you can store water up to here, it will not spill. Okay, up to here you can store. So similarly all these blocks can store water up to this particular height, it will not spill. Okay, what about this block? This block can also store water up to this height. So this is the water that we can store. Now you have to find the area and you have to return that as the answer. Okay, how do you solve this problem? Okay, so let's do one thing. Let us try to consider any particular block. Okay, let's take one particular block to build the logic. Okay, let's try to find out how much water can this particular block hold. Okay, let's just take one block randomly. So how much water can this block hold? See this block, let's try to fill water. Okay, let's fill water. It can store water, right? There is no problem. It can store water. Up to where can it store water? It can store up to here, no problem at all. This block is supporting it. Okay, now let's try to fill even more water. Let's see if it is spilling. Is it spilling? It is going to spill, it's going to spill, but this block will be able to hold it, right? So it will not spill. Okay, so what do I mean by that is we can store water up to here. What if we store more than that? It will spill at this level. It will spill, water will spill if you cross this particular level, right? It will go this side. So up to this level you are safe. Okay, up to this level you are safe. You can store water up to this level. What about from the right side? From the right side there is no problem for this level at all, because there is a block which is able to hold water. From the right side, when will we have problem? From the right side only we will have problem if we cross this particular level, right? Then it will spill. So from the right side you can store water up to this level, but from the left side you can store water only up to this level, right? So we have two levels for this particular block, right? Two levels for this particular block. So from the left side we can store water up to here, right? From the right side you can store water up to here, but here this water will get spilled. So what you will do, you will not be able to store up to that level. You will be able to store up to the minimum level of these two. So you can store water up to here, right? So no problem at all, water will not spill. So this is what we are doing. This is the logic, right? So what you are doing, for any particular block you are trying to find the left block that can hold it and the right block that can hold it, taking minimum of those two levels and subtracting from the height of this bar. That will give you the answer. Okay, let's see it. Let's break it down and let's see it. So for this particular block, if we have to find the water that it can hold, what we'll do, we will go to the left side first. We'll try to find which is a supportive block which can hold water. So what we'll do, we'll start building blocks, and we can see that left side highest block that we have is of height 4, right? Highest block left side that we have is of height 4. So we can store water up to the level 4. Okay, what about from the right side? From the right side highest block that we have is of length 5, right? Height 5. So we can store up to the height 5. Now minimum of these two levels is 4, right? Because if you take 5 it's okay, but water will spill from the left side still, right? So if it was given that it's okay to spill water from one side, then it would have been okay. But here, if you have to store water, you have to hold it from both sides. You cannot let it spill from either of the sides. So you will take minimum. So this height is 4, this height is 5. So you will, what you will do, you will traverse the array, go to the left side, go to the right side, right? So take the maximum of the left side, right? Maximum of the right side. Okay, now what you do, take both of these things, right? So let me write it neatly. Let me do one thing. Go to the left side, take the maximum of the left side. Go to the right side, take the maximum of the right side. These are your supporting blocks that will help you to store water. Now take minimum of both of these. Okay, so that will give you the height up to which you can rise. Okay, so in this case you can rise up to height 4, right? In this case minimum of 4 and 5 is 4. But what is the water that you are storing? Water that you are storing is 4 minus 2, which is 2, right? 2 is the height of your bar. So you can store only this much water. You cannot store entire water, right? Because this block is also taking some of the area, right? So you have to subtract from the area of this block, which is just the height. So you have to subtract from this. Okay, so take the minimum of maximum left and maximum right, and then subtract it from the area of the current bar, which is same as height of the bar because width is just 1. So what we are doing, minimum of 4 comma 5, that will give you 4. 4 minus 2 is equal to 2. So this block is going to store 2 amount of water. Okay, similarly you can find out for all the blocks and you can get your answer. Okay, so this is the simple logic that we are going to take. It is not as simple to build the logic. It requires intuition. I mean, it requires some thought process, and so yeah, this is one of the medium to hard level questions. So now it becomes harder because of one more thing, right? So first we look at that. So it becomes a medium to hard level question because see, brute force approach, even if you build it, you have to optimize it. There are two levels of optimization in this problem. Okay, first we'll see the brute force, then we'll see first level optimization, and then second level. Okay, so first let's quickly see the brute force. So what you're doing, so in the brute force you are taking every block, right? You are taking every block. What you are doing, going to the left side and then going to the right side, finding out the maximum on the left side, maximum on the right side, taking minimum of both, and then subtracting the height of the current bar. Okay, so this is what you're doing. So for every block, what you're doing, you are traversing the entire array again, because you are going to the left as well as the right side. So you're traversing the entire array for every block. How many total elements are there? N elements, right? So the brute force is O of n square. Okay, so we don't want this. We don't want O of n square time complexity. What do we want? Okay, let's try to see if we can somehow make a better time complexity first. This is the first level of optimization. So first we will bring the time complexity to O of n. How do we bring the time complexity to O of n? Okay, so what we can do here, instead of traversing the array each time going to the left, traversing the array each time going to the right, finding the maximum, why don't we store the left and right maximum, right? So what do I mean by that? So let's do one thing. In this case, let's try to build a left array which will store the maximum left value at each step, right? So what do I mean by that? Let's see. Okay, so first of all, so what we are doing, at each element, right, we are storing the maximum height we have seen till now. That is our left array. So currently the highest we have seen is height 2. Okay, for the first block. First block is of course the highest because it has no elements which is before it. So the height is 2. What about for the second? So it is having height 0, right? But the maximum is 2. So 2 is greater than 0. So we'll store 2 here. What about the third block? So it is having height greater than the previous maximum, right? So the height is 4. 4 is the maximum height. What about next block? So still 4 is the highest height, right? 4 is the highest for this up to this particular level. What about next block? 3 is also less than 4. So 4 is the highest, right? 4 will be the highest up to here. Okay, up to here 4 will continue to remain highest from starting up to here. Till when? Till it sees another highest block. Now which is this block? This block is having height 5. 5 is bigger than 4. So what we'll do now, 5 will take its place. 5 will defeat 4 and 5 will become the highest element up till the end, because there is no element higher than 5. So this is your left array. So we are going to store the left maximum, right, so that we can use it later. We need to use it, right? We saw in the logic. So similarly we will build a right array and we will store the right maximum. From the right side you are going to take the maximum and store it, right? So initially only 3, you are seeing the block 3. There are no elements to the right side, so 3 is the maximum. Next block is smaller than 3, so 3 is the maximum. Next block is also smaller than 3, right? So 3 is the maximum. But this block is having height 5. 5 is bigger than 3, so 5 will become the maximum, right? So 3 was maximum up till here. After this there is no block that is greater than 5, so 5 is the maximum. Okay, so now we have a left array, we have a right array. How do you use it? Okay, how do you use it now? Let's take any one block and try to understand. So let's say we take this particular block. How much water will it store? So what will you do? Simply look in the left array. Okay, look in the left array, look in the right array. Okay, look in the left and right array for this particular block, right? So what we are seeing, left array has a value of 4, right array has a value of 5, right? So from the left side you are seeing maximum block 4 that can hold it. From the right side maximum block is 5. So take the maximum which we have already stored in the left and right array. We need not do any calculations or we need not travel anything to find out. We have already stored it in the left and right array. So minimum of 4 and 5 is 4. Okay, now from 4 you subtract the height of the current bar. Bar is having height 2, so 4 minus 2 is 2. So 2 is your answer for this particular block. Do the same thing for all the blocks, right? So what you are doing, for each block you are just doing O of 1 calculation because you have already stored the left and right value. So you are just doing a lookup in the array and then you are iterating over all the n elements. So this time complexity is O of n, right? So the time complexity is O of n. It's simply O of n, right? You have reduced the time complexity from O of n square to O of n. Okay, let me just erase this thing here. Okay, but now what has happened? We have brought the time complexity down, right? From O of n square to O of n, right? But now the problem is that you are also using additional space. In the previous thing you were not using space. Here you have optimized the time complexity but you are still using additional space and you are using O of n space because you are building the left and right array, right? So you are building the left and right array and that is going to use extra space. Now you want to optimize it further. Okay, what is the best thing that you can do? You can best get for this problem is O of n time and O of 1 space. Okay, how do you reach to this particular answer? So let's try to observe. So what are we doing at each block, right? Okay, at each block we are finding the maximum left, maximum right, minimum of both and subtracting from the current array height. These are the 3 steps that we are doing. Now what is the deciding factor for each block? Let's see this block. What is the deciding factor, right? See, left side nobody's left side, this is the guy which is actually the limiting factor. Right side it is not getting stopped, right? It can still store more water. Right side is able to support it. Right side it can still store more water, but the left guy is limiting it. Left guy is limiting it and saying no, if you store more water than this it will spill. Don't store more water than this. I don't have that much capacity to support you. So what is happening is we will find the limiting block and we can do that while traversing itself, right? We need not store values. While traversing we will find the block that is limiting. Okay, and that is the only concerning block. So let's do one thing. Let us erase this and let's build the solution, and once we see how we do it, it will be much more clearer. Okay, so let me do one thing. Let me just zoom it a little bit and then we will build. Okay, so we'll start. Okay, so what we are going to do, first we are seeing the block. This side is having height 2. Let me take another color. This side block is having height 2. This side block is having height 3. Okay, so what we'll do, okay, first we will note these elements. So left bar that we have currently is having height 2. Okay, right bar that we have currently is having height 3. Okay, we will note these elements. Now what we will do, let us do one thing. Now if we have to decide the limiting block, which will be the limiting block? The block which is smaller, that will be the limiting block, right? Because as we saw in this case, the right block, in this particular case right block was not causing problems because right block was having more length, right? But the left block was limiting. So if in this case we have to see which is the limiting block, which will it be? It will be the left, right? 2 is smaller than 3, so 2 is the limiting block which may cause problems. So what we will do, whenever we have a limiting block, we will try to, okay, we will try to shift from that. So let's see this particular example. Left bar is having height 2, right bar is having 3, 2 is smaller than 3, right? So what we'll do, let us move to the next block. Okay, so let us move to the next block. Now we will see the next block. Next block, this particular height is 0, right? Height of this particular element is 0 and height of this particular element is 3. Okay, here we have height 0, here we have height 3. So now we have to find out how much water can it store. See, on the left side it has a supporting bar which is which can support it up to 2, right? So this will be the deciding block. We know that left bar is a deciding block because it is smaller. Okay, so this is the deciding block. So it will, how much water will it store? Just notice the length of the left bar. What is the length of the left bar? It is 2, right? Length of the left bar is 2. This variable is having length 2. And what is the height of the current bar? 0. So 2 minus 0 is 2. This will store 2 amount of water. It is true, right? We can see that it will store 2 amount of water. Okay. So we can keep an answer variable and we can keep on adding the answer. Okay. But let's just build the logic. So till now it can store 2 level of water. Now what we will do, again, this is 0 is height. 0 is a bar that is having less height, right? 0 is a bar that is having height less than 2. So what we will do, till now what is the maximum left that we saw? It is still 2, right? Maximum left that we have seen is still 2. Okay, because 0 is smaller than 2. What we were doing in the previous approach, we were just building the maximum left that we have seen and the maximum right that we had seen. Instead of building that array, we'll just use the 2 pointer approach, and we will just try to simulate the same thing while traversing the array, right? Instead of actually building the array, we'll just keep a hold of 2 variables that will try to simulate that. Okay, so now left is 2, right is 0. Okay, now let's go to the next element. Next element is having a height 4. Okay, now this is an element that is having height 4. It is having height greater than the left bar, right? So it is having height 4, so it will not be able to store any water. How do we know that it will not be able to store any water? Because it is having height more than any previous left elements, right? So it cannot store any water. Any water will spill from here. If we are seeing any element that is maximum, right? So how can it store water? Water will spill from here. There is no block on the left to support it, because left block is smaller than the current height, right? Current height is 4, left height is 2, right? So 2 is smaller than 4, so there is no element to support it on the left side, so it will not store any water. So this block will store 0 water. Okay, and but this block can support other blocks. Okay, so what we will do, we will change the left bar. Maximum left is 4. Okay, and what is the maximum right? So right bar will still have a height of 3. Okay, now there is again a competition between left and right bars. Now you see, height of left bar is 4, height of right bar is 3. Now 3 is smaller than 4. Okay, so now which is the limiting bar? 3 is the limiting bar, because 3 is smaller than 4. Okay, so if we have to move something now, which will we shift? We will shift the right bar. Okay, so that is what we are doing. Whichever is smaller, we will shift that. So let us shift the right bar. Let's shift the right pointer, right? And right bar will still have a height of 3, but we will shift the right pointer. Okay, so let's shift the right pointer. Right pointer has come to this particular place. Now we have to look at this particular bar. How much water can it hold, right? Do we care about what is there on the left side? We don't care, because we know that right bar is the limiting bar. Okay, so right bar is the limiting bar because it is having less height. Okay, that means that it is the limiting bar. So how much water can it store? How can we find that out? So it is simple to find that out, right? So just do one thing. What is the height of the right bar? Height bar is having height 3. What is the height of the current bar? Current bar is having height 1. 3 minus 1 is equal to 2. So it will store 2 amount of water. Okay, so it will store 2 amount of water. So let's add that in our answer variable. Okay, okay, now let us go to the next pointer. Now which pointer will you shift? You will still shift the right pointer, because your right bar is still smaller. So if anything is limiting, your right bar is limiting. Okay, so now we have come to this particular. Height is still 2. 2 is still smaller than the right bar, right? So 2 is smaller than the right, so still it can hold water. This block can hold water. Okay, how much water will it hold? It will see the right bar. See, we don't care of the left side. Left side is not limiting, right side is limiting in this case. So 3 minus 2, 1. It will store 1 amount of water. Okay, so the water that it will store is 1. Okay, now we will move forward to the next. Which element will we go to? We will go to this particular element. Okay, so till now our left bar was 4, right bar is 3. Now we have reached a element that is bigger, a element that is having height 6. Okay, so now what happens? Now 6, can it store any water? It cannot store any water, because neither it will support from the left side, neither it will support from the right side. It will anyway spill. Okay, because 6 is having very high height, so there is nothing on the left or right to support it. So 6 is the highest bar that we have seen till now. Okay, 6 will take the place of the right bar. Okay, so your right bar will change now. It will become equal to 6. So I will change my right bar, and my right bar has become equal to 6. So right bar is equal to 6. Okay, Now this block cannot store any water, so it will just store zero amount of water. Okay, because highest will be 6, 6 minus 6 is 0, it will just store zero amount of water. Now let us go forward again. Okay, so now your left pointer was sitting here, your right pointer is sitting here. Now we will move the left pointer, because now if anything is limiting, this guy will be limiting. 4 is the limiting bar. So what we will do, we will move the left pointer. So we will move the left pointer, and this left pointer will shift this particular side. So now our left pointer was initially here, and it will shift here now. So left pointer will come here, and right pointer continues to remain at the 6 bar. Okay, so now this bar is having height 0, which is the limiting bar. Left side, it is getting limited from the left side, right? If you have to take minimum of 2 elements, you will take minimum of right, we are taking minimum of the 2 elements which were the holding bar. So 4 will be the minimum, right? Here in this case, left side is limiting. So what will be the height of the limiting bar? That is 4. 4 minus 0 is 0. So height of the left bar is 4, height of current bar is 0. It will store 4 amount of water. Okay, so what we will do, in the answer variable we will add 4. Okay, now let us go forward to the next particular case. Next pointer will, left pointer will move here, right pointer is still sitting at 6. Okay, so now left pointer has come here. What is the height? Height is 3. Which side is limiting? Left bar is limiting. Left bar is 4. 4 minus 3 is 1. It will store 1 amount of water. Okay, now let me go forward to the next possible case. In the next possible case, again we will shift our left pointer, right? So this is the height of the bar, which is 2. Height of left bar is 4. Height of the current bar is 2. 4 minus 2, 2 is your answer. Okay, it will store 2 amount of water. Okay, now let us do one thing. Let us go to the next element. So what is the next element? Next element is 0, right? Next element is 0. Height of left bar is 4. Height of current bar is 0. It will store 4 amount of water. Okay, so let me add 4 to our answer. Okay, and now let us go forward to the next bar. So next time when you move the left pointer, what happens? Your left pointer comes here, your right pointer was already sitting here, right? Your right pointer was already sitting here, your left pointer also comes here. Now in this case you can do one thing. You can in this case, already the bar is at 6, it will not store any water, right? After this case, left pointer will go this side, and right pointer will okay, will also move. So in this case, what will happen is, when you reach left and right, okay, after this iteration, when they both are equal, you can stop after this particular iteration, and this will be a total answer. This will be the total water that you trap. 2 plus 2 is 4, 4 plus 1 is 5, 5 plus 4 is 9, 9 plus 1 is 10, 10 plus 2 is 12. 12 will be your answer. Okay, so let us do one thing. Let us quickly code the solution. So the O of n solution coding, which was requiring O of n space, that is easy to code. You have to declare two arrays, right? We will code the best possible solution, which is O of n time complexity and O of 1 space complexity, because you are just storing 2 pointers, right? So you are not using any extra space, you are not building any array. So let's code the best, most optimal solution here. So let's see. So what you have to do, you have to declare 2 pointers, right? Int left and int right. Where will the pointer start? It will start at 0. And where will the right pointer start? It will start at n minus 1. Just the left and the right bars. Okay, and we have to take 2 bars, right? Left bar and right bar, representing, okay, from the left side if any bar is limiting, it will be the left bar. If from the right side if it is limiting, it will be the right bar. Okay, so initially what will be their lengths? It will be simply array of 0, and this will be simply array of n minus 1. So first and last bars, that's it. Okay, until when you can keep traversing, till the left and right are okay equal, till that you can keep traversing. Okay, after this case, what you are going to do, after this case you will have to check two conditions, right? Which bar is limiting? Which bar is limiting bar? Okay, is it the left bar or is it the right bar? Okay, so we'll have to check that. So that's what we will check. So if left bar is less than right bar, we don't care of the right bar in this case. That means left bar is the limiting. So if you have to find the answer, you have to use the left bar to find the answer, because what you are doing, you are taking the minimum of both the bars, right? So the answer will be the left bar, because left bar is anyway less than right bar. Okay, so that will be the answer. So in this case, again you have two cases, right? What are the two cases? If the left bar that you are seeing currently, if that is greater than the previous left bar, right? So this is storing the previous left bar. Now if the element that you are seeing, if element that you are seeing now, okay, you are seeing now, if that becomes the next, if that becomes the highest left, okay, it will not be able to store any water. Okay, so let me do one thing. It will not store any water. Okay, if it is the highest. Okay, so let's take example that will be much more clearer. Okay, suppose this bar, see, it became the highest left bar. From the left side it is the highest, right? So it cannot store any water because there's nothing on the left side to support it. It is the highest bar from the left side, so it will not store any water. Any water will get spilled. Okay, so if that is the case, then okay, so we will see if array of left, if that is greater than your left bar that you have seen till now, then it will not store any water. Okay, because water will spill. That's nothing on the left to support it. So in that case, what will happen? You don't have to store any water, right? So let me also declare an answer variable, long answer, that is initially 0, and that will build up our answer. Okay, now if this is greater than left, what we have to do? In this case, we don't have to store any water. Let's write the condition for that. First, let's write the else condition. Here we'll write something, but first let's write the else condition. Now, else condition, it will store water, right? Else it will store water. So what? How much water will it store? You can simply take left bar, because left bar is a limiting condition, right? We have already given the condition. We are inside this if statement. So left is the limiting. So left minus array of I, right? Array of left. Okay, so this will be your answer. You can just add it to your answer variable, and this will be your answer. As simple as that. And you can also shift your left, because left is going to be the limiting, right? Okay, now let's go to this if condition. If your array of left is greater than left bar, then what happens? Simple condition. That bar will become your limiting left bar. Okay, so that's it. So left bar will change, because left bar is storing the maximum left that you have seen till now. So that will become this particular condition. Okay? So that's it. These are the simple. I will remove the comment so that you can just see the code properly. So the code is very writing the code is easy once you understand the logic. Okay? So let me do one thing. Let me zoom it out again properly. So this is the code, right? So if left bar is less than right bar, then you have two cases, right? If or else. So what is the first case? If the current bar is a maximum than any previous left that you have seen, it will not store any water. We are not adding anything to answer here, right? In this case, we are just initializing the left bar to that current height. Okay, else we are adding it to the answer. Okay, else this will become your answer, and then you can shift your left pointer. Otherwise, okay, if this case is not true, which case? This case is not true, that means your right bar is the limiting bar. So you can write the similar conditions, right? So if right bar is the limiting, I'll just write the mirror conditions here. Whatever we are writing, we'll just write the similar conditions here in this case. So in this case, what will happen? If array of right is greater than your right bar, again this bar will not store any water. You can just shift your right bar, right? Your right bar will become equal to array of right. Else what will happen? Else you can do one thing. You can store water. So you can simply do answer plus is equal to whatever is the height of the right bar minus the height of the current right. Okay, minus the height of the current bar, and then you can decrement your right. Okay, so that's it. And after all this is over, what you can do, after all this is over, you can just return your answer variable. Okay, so that's it. Now let me do one thing. Let me zoom it out and let us run this code. Let's see if it is working. Okay, it's fine. Now let us submit the code and see if it is getting accepted. So it's getting accepted. That's it. Thank you for being patient and listening.